Well, hello everyone. Hopefully you're in the right room and you do want to hear about chasing Gradle build speeds because that's what I'm going to talk about. All right. So you might have heard about Google. We're a little mom and pop shop. We run a search engine. We also happen to build AndroidX libraries, which are like a set of libraries that pretty much every Android app uses. So I will be talking about that. Google does a lot of things. I'm going to be focusing on that. And if you know, Google also doesn't really necessarily build everything with Gradle. Obviously, there's the whole other infrastructure, but I will be talking kind of the Gradle bits and what we use there. Yeah, so let's get going. So about me, I've been in Google for 10 years. 6 of those have been on Android team, and a lot of part of it was with working on support library that eventually became AndroidX. I'm currently a team lead working on build, test, and a lot of policy enforcement, so API tracking and whatnot. So I'm here to kind of like tell you about the story of our growth and kind of like more focus on like history, but in a focus of a build. And while you might not get any like really specific advice out of this talk, my hope is to inspire you that your build speeds don't have to suck, right? Like as your project goes, it doesn't have to go to crap, right? So that's what I'm trying to do. So if we go, like we're gonna get started a little bit of concepts, at least the way I think about it. So for me, the way I want to think about it, there's things that make your build faster and the things that make your build slower. And the project size, lines of code, number of projects, and so on affects your build speed, and usually in a negative way. But that tends to be like a thing that people want to do, is ship features, right? They want to do that, but it makes your build slower. But the opposite side kind of like is, or on addition on that, you can also make your build slower by adding more capabilities. So if you want to run KT-lint, or you want to do some static analysis, or you want to do insert a thing you want to do. And that also makes it slower, potentially. And then the other side is kind of the optimizations of the build. So what can you do to make it run faster, right? And that's, I think, while it's a delicate dance, if like how do you make it do all the things you want to do fast, it's tricky. But I think the part that I've seen a lot of teams struggle with is kind of the optimization step. It's really easy to add a new plugin. It's really easy to add new code. But optimizing your build, well, it's not really sexy, and it's also kind of painful. So that's what we'll be talking about. So where did it all begin? Support libraries started in 2011, so a while ago. And the focus was on kind of like extending what Android platform can do, and just kind of like provide some like a layer of a shim, so you don't have to worry about backwards compatibility as much. It was 8,000 lines of code when it started, a single library that we shipped. And it was using Make, the build system, which happened to be the build system that Android platform was using. So it's kind of like piggybacking on everything we have already. And it was written by an Android engineer, Diane Hagborn, which you might have, if you know Android Circles, she was there from the very beginning. If we kind of jump forward a little bit, we added 4 more projects. This is jumping to 2013. And this is the first time we add Gradle to our build. So now we have 2 parallel builds. And if that's ringing scary bells of like you have two build systems, well, that's what we had. At this point, we're at 52,000 lines of code, so we're growing in size as well. This is using Gradle 1.11, so maybe prehistory to many of you. And then this is AGP pre 1.0, so this is like really old stuff. And then 2 build systems, I said, not a great thing. Every little library you add, you have to have matching build files for one build system and another, and this is going to become a story as we build. Yeah, so in 2015, this is when I joined the team, so I will have a lot more context from there on out. We only use Gradle for essentially creating a Maven archive. That's the only thing it was kind of useful for at the time. No pre-submit testing whatsoever, like not even building anything. All we did is post-submit, YOLO, hopefully it works. And then, and Make is the only build system too. Like we don't even test Gradle. Like, if someone broke the build, well, good luck, sync it and learn that it doesn't work anymore. Jump forward, and I will be doing this in half-a-year increments. So when I say next, that's where it goes. We go by 15 projects, so it's a sizable growth, and then I will be showing lines of code as well along the way, so you can kind of track of where we're at. At this point, 15 projects, really kind of like picking up speed here. Our Gradle system can actually build device tests now and run them. Well, it seems very basic today for you. At the time, it was really kind of like, oh yay, we can do this now because we had to do Make and all of the fun platform things that we had to do to make it work. So this is like advancement for us. Jump again, half a year forward, we add a little bit more projects. But luckily for us, now we kind of shift gears where Gradle is the main build system. Make's still around because Android platform uses all of our libraries, and we can't just drop the support because, well, they're funding us, so we can't do that. We introduced Doclava, which was a tool at the time that we used for documentation and API tracking. We added Android Lint, Android Studio support, and then we finally have pre-submit, but we use Gradle, both in pre-submit and post-submit. And that's really helpful for us because now we're like a lot more sure that our build doesn't break randomly. And this is the first time around where we actually started like looking at build performance because we're like, oh, well, the CI is not great. Like, what's going on? And we just bumped the heap to 3 gigs of RAM, and we're like, oh, problem solved. Now we're done. Probably not going to have to touch CI ever again. Well, that's not true. All right, 2017 we jump, and then we start growing projects. Now we added 5 more. Like, we're at 41, and I think that kind of shows the pattern that we've seen at the talk this morning, for example, of like, you build .gradle files are getting 300 lines a pop, and you just copy pasting a single thing over and over again. And that's where we're like, okay, we're gonna have a convention plugin, kind of our own thing. So we shove it in the build source. We wrote it in Groovy because that was, exciting at the time. Mistakes. And then we also split our build.gradle in the root directory as well because it was doing a lot of things and it was kind of like doing very different things, right? There's publishing logic, there was kind of repo setup and whatnot, so we did all of that. And then we also enabled configuration on demand, which was kind of the incubating feature that is still incubating Gradle. And then we're using that, and it's making our builds better, right? Like our lines of code, it's like getting sizable, 300,000 lines of code is not a joke. So kind of recap of where we are. Okay, so project count going up, steady rate, not crazy. We're not like growing, hundreds, projects every time. And if we look at our build speed in pre-submit, it's kind of flat. There's nothing crazy, right? That we have not saturated the CI yet, right? CI has X number of cores. Our project count is kind of like a little under that, like so we're not really like impacted as we're growing new projects. A little bit of foreshadowing here. All right, we move forward. This is the time where we actually split our build into 2. And I really don't love to say that, but we did that because we had a secret project, Arch Components at the time, which is like a set of libraries that we ship for Android. And it was secret, and we couldn't launch it. We were developing in AOSP in public, and then we had all this stuff that we didn't tell people about. So we split the build into 2. It was a miserable experience for me as a build engineer, but hey, that's what we had to do. This is the first time we added Kotlin. Again, doesn't help the build speeds. We started really working on like Maven plugin, kind of enhancing, making sure we ship our sources. We started doing error static analysis, with error prone. So all of this is kind of like slowing us down a little bit, right? And then we also start, like what can we do to improve? We started moving our Groovy code to Kotlin and Java. And we started finding that like, oh, like when you have like statically compiled language, you can actually get all these benefits of like not crashing on runtime randomly. And then we also started moving our library versions and dependencies into build source because like Will is so much better than having it scattered across like hundreds of files. I want to update JUnit to a new version. I don't want to touch 400 files and like have a an interesting time of merge conflicts and all of that good stuff. So that was a big kind of help for us. And then yet again, we just keep cranking the JVM args, like we're going for 4 gigabytes. Okay, good, that's good enough for everyone. And this is the first time kind of in our development where we got like a full-time dedicated build engineer. Up until that, it was kind of like 20% project, like whoever jumps in, makes it better. Yeah, keep going. We are still split into 2, not great. Our project count is growing. We add Jetifier, which, if anyone is like getting flashbacks about this, well, we added it to our own build because that's the year we migrated from Android.support library to AndroidX, and we package migrated everything, and it turns out a lot of tooling had a lot of dependencies on having package hard-coded, so that was something we had to add to our build, and it kind of made it slower. We decided that splitting out JVM tests into a separate builder, great idea, because, well, we were doing everything in one big builder, and if you pull the tests into a separate thing, well, you could potentially double your speed depending on how slow your tests are. And then we also migrated all of our build source to Kotlin. We decided that Groovy and Java was just like causing us pain. There's no reason to keep to that. And then we started adding plugins that were kind of like one per type of project. So if you had a Java project, you apply AndroidX Java plugin. And if you had an Android project, you had AndroidX Java plugin, or Android plugin, and so on. So like it allowed us to kind of like do a little bit of like kind of like this is the flavor of project you are, and this is the conventions that we want to apply for those. Kind of jump forward, we finally merged the builds back. And one thing that I kind of mentioned, did I not mention? I did. Okay, anyway, we merged it back. And the nice thing for us here is when we merged back, we also got a chance to kill make. You probably didn't hear about this in the meantime, but like we were suffering all the way along. Bolting on Kotlin into make is not a fun experience. So like having 2 build languages where you have to kind of like support both of them at the same time was not great. So like merging it back and having like a one thing that we really need to care about, it was really beneficial for us. as we added Kotlin, we also realized then we have to like start tracking it, right? Like you need to document it. So we had to include Docker. Yeah, yet another, we have 2 documentation tools. And then we added API tracking with Metalava, which is our tool that we wrote for tracking kind of Kotlin API service to make sure that we don't break binary compatibility for our users. So now we have 2 API trackers, two documentation tools, and we're adding to all of this. This is the first time we enabled local cache for Gradle. Really annoying that Gradle has a default of not turning it on. If you see anyone from Gradle here, maybe you should nudge them to change that. Another thing we do is we also split out our test APKs for Android into a separate target because, well, again, this is very similar to JVM host tests. Like, if you can just build your tests and then start running them, you get a lot of benefit of, like, you don't have to run lint to be able to start running tests. So, like, splitting in a separate target, that was kind of like in a pattern, and you'll see it through the time. We also created this thing called affected module detector, which you might have heard from Dropbox, but they kind of copied our code. But that's okay. Open source, that's how it works. But what it does, essentially, if you give it a set of files, I changed 3 files, it will tell me what projects in Gradle are affected. Like, if I change this file, is any project depending on this, or is the project itself changed? And that allowed us to really narrow down of what we test. So that was like one thing we did. And then yet again, we cranked JVM to 8 gigabytes. This is looking pretty good. All right, we jump a little bit again. We're really starting to grow in terms of project. Now we're close to 200 projects, so I feel like it's fairly sizable, especially for 2019. We started adding custom lint checks. Lint not really fast. You add more lint checks, well, it turns out it gets even slower. We started tracking Android resources just because we want to make sure that if you expose a new string or a new style or something else in our AARs, the developers take, we don't accidentally remove it and then break our developers. We started doing max depth version testing, which I mean by that is normally we pin our libraries to use the lowest version of a library dependency we can. But of course that exposes us that if someone goes and removes some API, you don't want to break on it, right? So what we do is we essentially dynamically have a separate build that swaps and inserts the essentially tip of tree dependency like at head, and being able to kind of do that testing to make sure that we don't break ourselves that way. For the optimization side, we start doing a migration to lazy tasks. It's the kind of thing that was novel at the time, but for us it was like, oh, like you don't actually have to do all this work in configuration phase. So just kind of like moving on and like starting to fix all of it. And it also expanded our affected module detector onto a lot of more tasks. So like for example, lint. Like if your module has not been changed in the files that we touched in the PR, like why even bother running lint for those modules? So like that's another way to kind of cut down on time. This is a huge growth. So we grew 111 projects. For us, it was like drastic bump, and this is because of Compose. So if you might have heard of Jetpack Compose, which is our like UI framework, it was a big project. There's a lot of people working it. They wrote a lot of code. As you can see, our Kotlin jumped to 270,000 lines of code. And of course, it made our builds a lot heavier. The build got split again because Compose at the time was secret. This is a pattern you see, like secret projects. We keep splitting the build, and it's not a fun time. But we started doing kind of like more things there. We started tracking. We started doing KT-lint because we started adding so much code. We wanted to make sure that our like code is consistent across. So KT-lint runs there. We started doing build metrics on the library. So like how many methods are there in this library? How big is the jar? So we'll kind of like have overtime graphs, and we're able to kind of track as we're growing. But then jumping on a kind of the optimization side, this is the first time where we realized that like every laptop is not the same as every CI machine. So maybe you don't need to use the same JVM args between the two. So in here, and the first thing we actually switched on is we made it so that CI always pre-allocates all of the heap. There's no reason for us to grow because we know we're going to get to 8 gigabytes. So that was a big thing and actually helped us with the build. We also moved to a single plugin. So this is kind of the reversal of our multiple plugins. We kind of learned that we ended up making like the same code change to like 7 different plugins. We merged it all into one, and it's reactive to a plugin. If Java plugin is applied, we do a little bit of work. If Kotlin plugin is applied, we do a little bit of work, and so on. We moved our build source tests. Another not so great decision by Gradle is that if you have build source tests, they will run before everything else when you just want to do configuration of the main project. Move that out, saves us some time. We also really focused on task up-to-dateness because we're like starting to use the cache more and more. So we really did like a lot of enforcement for task up-to-dateness. So essentially we set up a system where we run our build twice. In the second run, there should be no tasks. And of course there is. So we have an allow list of like, oh, we know these tasks are bad, and we slowly started clamping it down. And it even helped us catch like regressions upstream, where sometimes Android Gradle plugin goes and makes a thing that causes tasks not to be run correctly. So that was nice. Yeah, let's keep going. Next thing is we actually started doing testing. Surprise, surprise, for our build logic. It's sometimes not very obvious that you might want to do that, but Gradle provides you a Gradle test kit that allows you to kind of set up your plugin in a way that you can maybe have like a demo app or your demo library and then do the testing that way. So you have a much more predictable thing as opposed to like, let's ship to production and see what happens. The other thing we started doing is really kind of containing Gradle. Like all of the Gradle outputs, like Gradle home, Gradle temporary directory, like everything we shove in a single directory. And if someone wants to nuke that directory, we know we cleared everything. Whereas today, if you just use vanilla Gradle, you run a build, you clean your build directories, and you run again, you're actually going to get stuff from different types of caches, transformation caches, download caches, configuration cache, and so on. So we really started to honing down on like containing all of that and allowing us to do a very reproducible type of environment. And the other thing that was kind of like big brain moment for us is starting to be able to use workers. So our Metalava, which is our BI tracker, it was just a JVM process we spawn off. It runs a lot of stuff, and then it comes back at us. And we kind of learned that with workers, you can actually have multiple tasks run at the same time within the same project. And that's really helpful when you have many tasks. And we were tracking like public API surface, internal API surface, experimental API surface. And it was like same task, which just blocked on each other. And now we could use all of the cores we had. So that was a good move for us. Again, zooming out, let's look back on where we are, right? The graph was pretty flat. And then we suddenly started really picking up. And like, even like the last half year, like 111 projects, that's like a big growth, and especially for us, the build team didn't grow by the same proportion. It's the same build team. And kind of like, look, I tried to align the graphs a little bit here, but the code, is going up. Java is pretty steady drumbeat, but Kotlin is really shooting up because of Compose, right? So like, we're really growing in that. And you can kind of see the build was flat for a while. That's the last graph you saw. And it's really started to climb up. So if we kind of zoom in a little bit of like what did happen in those little parts, I will kind of walk you through some anecdotal things that I found that were interesting. So the A point was when we merge Arch components back into the main build. Turns out when you have two builds that are separate, they build pretty fast. And if you merge them together, it gets slower because you have more projects. B was actually the drop in, so lower is better because there's a number of minutes in CI. So dropping down in B was 8 gigabytes of RAM of heap for us. So that was a nice decrease. C was a regression when we upgraded to Gradle 5.0 because they had performance regressions. D was up as well when we started tracking our internal API surfaces. Initially, we only tracked our public surface, but we also wanted to make sure that we don't break our libraries within each other. So we started tracking that. So that also kind of shot up. For E, you can start to see like a very steady climb over there. That's Compose. We hired a lot of people to write a lot of code. And it turns out that causes your builds to go up because they write a lot of code. And a lot of Kotlin, which is like not very fast to compile. And then F is a huge drop down when we actually moved Kotlin compiler out of process. We had a bug that we hit specifically for CI where we couldn't run Kotlin out of process, like we couldn't have a Kotlin daemon. And finally, that bug was fixed upstream, and we were able to move back the separate process, and that gave Gradle daemon way more breathing room in terms of memory, and that made our build speed up drastically. All right, keep going. 2020, we'll keep moving forward. So the other thing here is you will notice is that we actually split a AGP, like Android Gradle plugin, between Compose and our main project. This is another pain when you split the build. Like, people can start diverting. And so like, if you're in monorepo, it's not a fun time to have managed like, oh, does it work with this studio version? Does it work with this one? And so on. So that was becoming slightly painful. We started doing work with integration of Android Studio. Like if you use inspectors, for example, for Compose, we kind of had to do like cross-team collaboration where we had to build some stuff in our repo and then also in Android Studio, and then kind of like started depending a lot between each other. We also started a builder of building like head of Android Gradle plugin and AndroidX to making sure that we don't regress. So like when the plugin evolves, we actually don't kind of break. And that was actually a big benefit to kind of the ecosystem you didn't get to see. But like when something breaks, now I go and yell at the Android Gradle Studio team like minutes after they broke something, as opposed to it coming from Bug Tracker months later. So we added support for Roboelectric. That was also nice. So like that our developers could like run tests a little bit faster. And then on the kind of the optimization side, we enabled remote cache for local builds. Due to corp policy, which I'm sure some of you run into that, we couldn't do it in the CI because we wanted to have builds that are very reproducible and they are not like going to the network and fetching things and so on. So at the time, we could only do local builds that were remote caching. So Joe would go build and run a task, and then Mary, when she goes and runs it, it goes and caches the same way. We spent a lot of time doing cache updated cacheability fixes, because when we started using the remote CI, we started actually seeing a lot of issues where it was issues with paths. So if you had a place in one place and in the other, and we were hitting all sorts of problems there. And then we did the JDK 11 update, and that was also very nice. All right, Compose merged back in. Yay, awesome. We have one build again. We set up a GitHub mirror for contributions. So plug if you want to contribute to our code base. Now you can also do it on GitHub. But it also actually added build complexity, because normally our build runs completely in hermetic mode. Like we download Gradle, all of the dependencies are in Git. It's kind of like self-contained. You go download it and you can like plug off the internet and you're going to be able to build all of it. Whereas GitHub, that's not really how it goes. So like being able to do like the flexible, like, oh, you can reach network now, you can go download some of the dependencies, here's the verification we have to turn off and so on. So that like kind of made our build more complex. We finally learned what input normalizers are. Turns out it took us to 2020 to get to know that. But actually that was causing a lot of invalidations for tasks, because we started building a Compose compiler plugin for Kotlin. And if you don't normalize, it will be a different jar for every local machine. And essentially it made us kind of have no cache hits for anyone who was working on Compose. And we kind of missed it because we didn't really see it someone's machine of like, why is yours being so slow? So we had to kind of like learn about that and fix a lot of it. We wrote a bunch of like our docs implementations here to kind of like make it an explicit list. Before we were trying to be clever and doing dynamic docs. I would avoid that. I highly suggest having like a complete list of what you want to publish. As a compromise for Compose team merging back into our main build, we also have to give them a latch or escape hatch for Studio. As some people who might have mentioned a couple of times here, like Gradle sync can get real slow when you have that many projects. And here we're at 400. Not great. So the escape hatch was essentially developing something similar to very similar to Dropbox Focus, which essentially we say like, oh, I want to open like this set of projects and this set, and that allowed Compose team to continue having that nicer experience of only opening like a couple of hundred projects as opposed to the whole thing. GC tweaking. That's a pattern. We just keep going. We enabled parallel GC. Turns out it's actually a better type of GC for JDK 11. And in CI, we actually gave it more RAM, so it's now 16 gigs in CI. In the local, we had to keep it as 8, because turns out if you run Android Studio and Gradle, and then sometimes Studio launches another daemon of Gradle because it's running a different Java version, you kind of use up a lot of RAM, and like if you go top end Mac, there's a peak of how many gigs of RAM you can get. We also started doing a lot more on build output validation. So like we essentially detect if it's a new type of error we've never seen and we fail to build on you. And then this is the first time we forced we have owners essentially files in Google, which essentially is like who can approve a change. And this is the first time we kind of used set no parent, which essentially means like nobody except for a select few people in a team can review our build changes. Because we ended up finding that people would accidentally go and shoot themselves in the foot because, well, writing Gradle code is sometimes hard. Let's see. We added a couple more features, which essentially was just kind of like bundling in some artifacts inside of the others. So it's not a huge growth, but like our project growth just keeps going, right? We are, at pretty sizable numbers here. The big thing here for us kind of in the optimization side, adopting version catalogs, we moved out of build source to defining all of our dependencies to build catalogs, and actually like helped us reduce build cache invalidations by like a dramatic amount, right? Like not every bump now invalidates everything. And then also CI, just keep cranking, 24 gigs now. All right, keep moving. This is the kind of monumental stuff for us because Kotlin surpassed Java in terms of lines of code. Which essentially kind of like shows kind of the trend of where Android at least is going is Kotlin first, right? So that was kind of like the thing, but also means the Kotlin tooling is that much more important now. For us, we enabled dependency verification as kind of like our extended effort of like trying to make sure that we know what we build and what we ship is actually the stuff we trust. We also started a third build tool or documentation tool because why not? This one is called DACA. This was a rewrite of DACA that we had on top of DACA plugin architecture. So a new build tool, now we have 3. Let's see, configuration caching in warn mode. We have to enable that, or we wanted to enable it to get the benefits that we've seen from several people mention it. And we started fixing a lot of issues, so we're kind of slowly going down that list. We split our build source into two parts, public and private, and we only load on the class path of build.gradle the public bits, and then we runtime inject the other ones, and that helped us kind of reduce of what people are able to poke into our code, and also helps with validations. If you want to chat about that, catch me on the side and we can talk more. We also started tweaking Kotlin daemon arguments. Turns out now we have 2 daemons to worry about, so you also got to do that, and we kind of started doing arguments there. JVM testing, yet another set of arguments. I don't know if you're sensing the pattern, but JVM arguments, very important. We had to bump that to 2 gigs because we started just like ohming on random tests, right? So it's not great. And this is the time we actually run kind of a collaboration of Gradle of enabling Gradle Enterprise for our GitHub mirror of our project. And that actually led to a fair number of remote cache restoration fixes where we were like accidentally using absolute paths or whatnot. All right, if we keep going, we add Max support. Well, Max shipped an ARM version, and so we needed all of our tooling, JDK, and everything that has like a native component, AAPT and AGP and all of that good stuff. So we added that, kind of in a way it makes build more complicated. JVM for tests, go ups again. It's like, again, pattern you might have seen. This is the big one for us because we enable remote cache for Gradle in CI. It was a lot of battle to get the right approvals from the right people and the thing, but the impact was massive. We were able to turn off the affected module detector, which is essentially a big hack around Gradle, and we left it only for tests because we haven't quite solved that. And then the remote cache, only pushes from CI, and then all of the local developers only read. So that also helped us a lot with reproducibility of issues too. So it's not someone like local pushed some bad cache entry, and then now the rest of the team can't work. Yeah, and then there also is a big push for team to actually start adopting remote cache. Some people choose not to, but when you show them some numbers of oh, you can run all of build in X number of minutes, then they're a lot more convinced. And then yeah, more fixes on remote cache restoration. So today, where are we today? We are at 657 projects and over 2 million lines of code. I would say it's a pretty sizable project. You've seen some slides flexing, and this is like a side project for Google in a way. We have a monorepo that's a real monorepo, and this is just Android libraries. So for us, I feel like we've really grown. We're started with 8,000 lines of code. So even through my tenure, it's been massive, right? We added JVM-based layout lib testing, so screenshot tests without running an Android device, which is kind of more capabilities, slower build. We did a JDK 17 upgrade. Turns out it made our build 10% faster by just upgrading to JDK. Who knew? We actually turned down all the other documentation tools. We're down to 1. Yay. It actually simplifies the build, makes things better, but we were not ready. The rewrite took a long time, and it's one of those things, migrations, if someone tells you migrations, it's never as fast as you think it's going to be. And then, the other thing that our team really started focusing on is profiling builds. Using UTrack, YourKit, or any Gradle profiler. Just start really analyzing your build as if it was an application, right? If it goes and does one thing, you might be really wasteful. So people talk about configuration phase being slow in Gradle, right? It might take 60 seconds, and if you look at what's going on in there. If you have 600 projects, any one expensive operation gets multiplied by the number of projects you have because it's currently run serially. And so looking and finding bugs like that is pretty important. So an example of that, Gradle, core Gradle, the tool, was doing a string format in one of the operations where they wanted to log some data, and that was costing 100 milliseconds. There was a single line change that I submitted to upstream Gradle that made our configuration 100 milliseconds faster. Right? That might not seem a lot, but if you have 100 of these, that's a second. That you're really talking real numbers. And then so that's kind of the thing I want. We really started focusing as a team. So kind of taking a step back again, how are we growing? It was steady. It picked up. I was like, okay, well, it's fine, but we are not stopping. So I think it's one of those things where it looks kind of scary when you look at the graph, something like that, right? Lines of code. Kotlin is just skyrocketing, right? It's really going up in this, overtaking Java. So let's look at some examples of kind of fun things that happened in the meantime. A was a Kotlin 1.4 upgrade. Our builds got slower. Turns out newer version had a bug in the Gradle implementation. B was actually upgraded to 7.6 of Gradle. It's actually improved our builds. So sometimes it is worth it. So that's the kind of thing where you gotta measure. If you don't measure, you're not gonna know what you get out of it. C was an example where we moved to only building one variant of our projects. So by default, if you're depending on what kind of command you run, you might build like release and debug. Well, it turns out in certain CI scenarios, you only need like only debug or only release. So that was kind of for us a big drop there. And then in D, you can kind of see some crazy spikes, and that was we had some outages. That was not fun. But then the steady decrease was the enabling of remote cache. So we were like rolling it out per different builder, and then it was slowly getting better and better. So that was pretty exciting to see. And then just not to kind of be like, oh, they have a lot of projects. So this is the artifacts on maven.google.com that ship from our code base. So it's not just like kind of like imaginary, I created 600 sample projects, look how fast he's doing. Like we are shipping, I think the last time I looked, it was a little over 400 artifacts, like unique Maven artifacts. And it's like not including versions, just like artifacts. So it's a scale not just in the core project, which has demo apps and test apps and all sorts of things, but like even the stuff that we ship. So we're kind of going. What's upcoming for us? I think for us, big one is going to be Gradle project isolation, and you're probably going to hear about this for the next 3 years because it's going to take a while to launch. But it's like really focusing on that feature, and you should like look up and read what it is because it's going to affect you in the future. But it will allow essentially Gradle's configuration to run in parallel of all projects at the same time. So speed up of n number of cores you have, and similar for Gradle Sync in Studio, which is going to be huge for a lot of developers. The other thing is working on shadow builds, meaning that we want to test essentially against tip a tree nightly of Gradle. Like, are we going to break when Gradle 8.0 ships, right? We want to be ready for that. Same with Kotlin Gradle plugin, same with Next.jdk and so on. So being able to kind of get ahead of it so you know when something breaks, like kind of like at the daily basis. If Gradle introduces regression, we know the next day that it did happen, right? So that's the kind of thing. And then updating JDK, like we're in 17, would be nice if we were on 19, right? Cool. Some of the takeaways. So I think like everyone is convinced here, but like maybe not everyone outside of this room is convinced, but that productive engineers make better quality products. That's what we found within our team. If someone is not twiddling their thumbs or going off to Twitter or creating memes, like they end up doing a lot more productive work. So like going from a couple of minutes build to a couple of seconds build, it makes a huge difference. The other thing is monitoring. You got to monitor if you want to catch regressions. Like if you currently don't have any sort of monitoring of how slow your build is, maybe that's the first thing you do when you get back to your office. And that's the only way to catch regressions. And we've caught many. Like we've caught stuff in EGP and upstream Gradle, Kotlin Gradle plugin, and so on. And we catch some stuff, but like your build might be unique, and you might not get the benefit of what we do. Keep your tools up to date. JDK needs an example. Like if someone told you your build can be 10% faster for like just upgrading to a new JDK, like wouldn't you go and do that? Like that's the kind of thing. Same with Gradle. You're gonna want to use the latest version. They do a lot of improvements, sometimes regressions, but hopefully improvements. And then also read release notes as those tools come out. Like there's sometimes interesting features and things that you might want to poke at. And speaking of features, some of those features might be really painful to adopt, but it might be worth it. So for example, configuration cache. It was a multi-year effort of trying to get to it being enabled. But once we got it, the impact was big. So that's the kind of thing to keep in mind. And so finally, I guess to like wrap up, like all I want to kind of say is that if you have a project growth in terms of like code and everything, it doesn't mean that linear CI times. If you get 10 times more code, it shouldn't be 10 times slower build. That's kind of like if you take anything away, that's what you should take away. And then the kind of like one big elephant in the room, right before I ask for your questions, is I didn't talk about testing. I only talked about build. So testing on Android is kind of a pain in the butt because you have to run on physical devices for most part, or emulators. And inherently, Android can only run one thing at a time. So you have to have n number of emulators or n number of devices to do any sorts of parallelization. And our graph is not looking hot. If we started forever ago, we had 10-minute pre-submit for tests. That was good times. I was looking at that and like I had a tear when I saw this graph. I was like, wow, that was good times. And now on average, this is average, not even P90, it takes 60 minutes for tests. Just developers are sitting there and waiting for CI to come back for an hour, right? And this is like, we are like only detecting what needs to run. We're only running small and medium tests and like doing all these optimizations. And it's still kind of crappy experience. And P90 is even worse. Like running all of our tests in AndroidX is around 7 hours worth of device time. So it's wild, right? Like we do run like 60,000, I believe, Android tests. So it's a lot of tests, but that's the kind of thing. So what I want to say about this is we don't have a solution for this one yet, but that's the next focus for me and my team. And if anything exciting comes out of it, well, maybe I can come and do another talk about that. So I want to thank you for coming and listening to me. I see at least some of you are awake, so that's good. And then now it's the time to ask any questions if you have any.